Welcome. I'm Patrick O'Leary, an Assistant Director for Scientific Computing team here at Kitware. Thanks for joining our webinar on what's new in Trame. I'll provide a quick intro to Kitware, then Sebastien Jourdain, the creator and lead architect of Trame, will take over. Feel free to type questions into the chat. We'll take them after Seb's presentation and demos. A little about Kitware. Kitware was founded in 1998 and has been 100% employee-owned since 2020. We have about 220 employees across the US and Europe. Our focus is on software and AI research and development for government, industry, and academia. And at Kitware, our goal is to make the world safer, healthier, and better informed. What we do. We are a collaborative company working with our government, academic, and industry partners. Kitware works on large, small research efforts, custom development, training, and support. We have deep expertise in a variety of industries such as image analysis for healthcare and life sciences, analysis and visualization for energy and manufacturing, and image and video forensics for defense and intelligence. Throughout Kitware, we are AI focused with a strong emphasis on ethical and explainable AI. Open source and open science. Most people know us from our commitment to open source platforms we've helped create. You can learn more about us and all of our open source technologies at our website, www.kitware.com. Today we are spotlighting Trame. In a little over 3 years, Trame has gone from just a few of us working with the code to approximately 150,000 downloads per month. We are so excited about Trame and Trame's potential for your project. Finally, remember you can type questions into the chat at any time. And with that, I'll pass it over to Seb.
Thank you, Patrick, for the introduction. So, hi everyone, I'm Sebastien Jourdain, the creator of Trame. Today I will mostly cover some recent improvements we've made to Trame. But since I don't know how much you know about Trame, I'll start with a brief introductions in terms of capability and architectures. And keep in mind that we already done a webinar on Trame and the introduction, so you can always get access to the recording and follow the previous webinar to go more in depth. That's what I'm going to do today. After that, I'll jump right into some of the new syntax and best practices. I'll also cover some of the new widgets that we've been working on, and I'll finish with a demo of a small open source application and demonstrator so you can have a feel of what's possible to do with Trame. Along the way, we'll have a series of polls so that I can better understand what we can do better to serve you. So let's start with the first poll to have a feel of the level of experience you have with Trame. So the first question that we have is, what is your experience with Trame? And the idea will be like, never use it, novice, intermediate, or advanced. And so I just want to make sure I understand the crowd that I'm talking today to, so I can better adjust my communication. So far, there's almost 40% of never used it, and even distribution, actually not even. We've got same amount of novice, 25%, and intermediate, and advanced 15% or 13%. That seems pretty cool. Thanks for the poll. I guess So if you don't know much about Trame, I think the architecture diagram that I'm sharing now give you a good background on the idea behind Trame. And first of all, the way you need to see Trame is just a Python library that bridge a web UI to a Python application logic. Technically, Trame focus on 4 concepts for you to build your graphical user interface. I'll start from the right and going to the left. I should swap my diagram because it's easier to explain. So so you'll start with the UI template, the user interface, which will be the content of a page where you will start placing widgets. Think toolbar, content, footer, drawer, and then you start filling up those placeholder that you want to complete. The next stage is the widgets. The widget itself can be as small as a text element, a button, a slider, or as big as a 3D view from VTK or ParaView, or any kind of charts from Plotly. But it's still a single entity that you place in your UI element. And then once you've got those widgets that you've laid out into your page, you can deal with events that let you attach Python method to action that are happening on the client side. By client side is in the web UI, in the browser. For example, you click a button. When you click a button, you can attach a functions to that, so you can trigger actions there. And then finally, the most important is the state that lets you drive the presentation layer and also react to it when it changes. Think of it of like, I've got a slider, the value that the slider is driven by or modified. Like when you move the slider, you're modifying the value of that state variable. Or if on the server side, you're modifying the value, then the slider will reflect the new value by shifting its locations and reflect the current state. Then it is the responsibility of Trame to keep the state in sync between the client and the server, while letting you work in Python when half of the work is technically happening on the JavaScript on the presentation layer. In fact, each component or widget is actually a Vue.js component that get exposed in Python for convenience. Thanks to that abstractions, each component or library of component is a standalone Python package that can just pip install to start using it. By default, Trame comes with a standard HTML tags for creating a web UI, and along with some helper component that you kind of check out the life cycle of the page, things like that, or execute JavaScript code directly. But additional library can be installed to bridge the server-side library like VTK, ParaView, Plotly, Matplotlib, Leaflet, and much more. For user interface, Trame offers several options like Beautify, Quasar, TweakPane to easily create stunning graphical interfaces. Basically, you pick whatever framework you want to rely your UI to be based on. Just to give you a scale of what is available today, we have about 450 components across 25 Python libraries. So now that we've covered the big picture, let's go over some detail.
Before you get started, Seb, I have a question on that. I'm sorry.
Okay, go ahead.
You mentioned you have about 450 components available in Trame via Python. Does that mean that you wrote 450 classes by hand to expose those web widgets?
That's a great question. Actually, no. The way it works is for some of those components, we do write them by hand. Typically, when you deal with VTK, Plotly, we have like one component or one giant component where we handcraft the communications between the client and the server. But for the libraries, the graphical one like Vuetify or Quasar that has like more of hundreds component in itself, they tend to expose their API as a JSON descriptions of their widgets. And we actually have a tool that even you can use and describe any kind of VTK.js library out there. And it would generate all the Trame code for you. So we, for example, in Vuetify, when there's new versions of Vuetify coming up that brings new component, we just rerun our scripts and that regenerate the full library and the full Python. So we just have that fancy tool that is very convenient to use, but mostly for those big libraries. So one usage is you can grab anything that's out there that is Vue.js and you say, oh, by the way, I want it to be available in Trame. You can describe the API unless it's already described, and boom, you can like generate the Python code. What we try to do is publish it to PyPy, so nobody has to worry about it. You can just pip install it. But we just expose the one we tend to use in our day-to-day projects. So hopefully I answer your questions, Patrick, from the crowd, but feel free to keep asking questions during the webinar. And thanks again for interrupting me, Patrick. So capabilities. So on the previous slides, we cover all generic and we didn't really cover how generic and powerful that is. If you think about web UI, you start thinking HTML and JavaScript. But with Trame, you can describe the web UI in plain Python by simply laying out those components and defining properties and events on each of those components based on what you need. And with exactly that, you're capturing what modern web development is all about. But with Trame, there is a lot of boilerplate code and technology stack that just disappear because since the component or widgets are driven by property, you can attach dynamic states to those properties and get dynamic UI behavior out of it. You can even monitor changes on the Python side too. I've mentioned the slider before, but think of a slider that is driven a state variable. When the UI modifies its value, you can listen to the change on the Python side and attach logic to that, such as method executions or anything else. Then when an event occurs, such as a click or a mouse drag or the mouse enter regions in the screen, you can attach method that will be called automatically on the server side when those events occur on the client side. Finally, from time to time, you may need to leverage some JavaScript expressions to conditionally render or adjust the style of a component based on some complex logic. So should I see the error message? Well, if there's no error message, I should not show you a panel with the error message. So you can create conditions by simply writing JavaScript syntax expression directly in a Python string. As you can imagine, I'm skipping some details, but the main gist is fully captured here. And in that regard, it's, to my point of view, fairly capable. There's really no limit with Trame in many, many ways. So before moving to the poll next, let's see if we have any other questions, Patrick.
Not at the current time.
Okay, thank you. So poll question 2, what attracted you to Trame? Is it the visualization capabilities with VTK and ParaView? Is it the Python libraries available, meaning Plotly, Matplotlib, Leaflets, and NumPy, PyTorch? I don't know. Is it the fact that it can run anywhere, meaning laptop, desktop, client server, in Jupyter, in the cloud, on HPC? Or is it like simple the client server architecture by just doing plain Python code, so exposing a UI and get that available through SSH on the web and so on, or something else like the GUI options compared to the others library that offers similar features, the remote local rendering, the AI, the Python-friendly approach. Like those are the options. Looking at the poll, it seems that everyone is definitely driven by the visualization capabilities between VTK and ParaView, which is great. I mean, that's really the strength of Trame. And then run anywhere also seems to be very appealing with 75%. Next runner up, we've got Python libraries with plotlies and so on, and simple client-server architecture. Great. Well, thanks for those insights. And let's go into the deep dives of what has changed and what we've updated on Trame. So while the core of Trame did not change, we've been working to normalize application development with base classes that enable method decorations while streamlining Trame usage pattern. If you look at the documentations, each example that we have crafted is really trying to dissect and present you with just the element we want to show you. And in that regard, we don't necessarily do a good job covering or you will do a real application in real life. And in that sense, on the left of my screen, you can see like a tiny example similar to what you could see on the example available on the website, where we have an infrastructure to get a server. From the server, you can get the states. Then you can like lay out all your functions that you want to listen to the states. You kind of inline the layout, the UI piece that you want to do, and then you start the server, just like basic standalone scripts. But that doesn't really scale as productions or application-ready solutions. And while we've been building more and more applications, we've created decorators to skip class inheritance. But at the end, we thought that providing a base class for creating a Trame applications was providing some really good capabilities. And we'll see more later with Jupyter how those capabilities just translate thanks to the fact that you're just inheriting that class. So rather than just laying out everything flat, you can create a class. As long as you inherit the Trame app from the Trame app import, you can like instantiate your application, or you can instantiate many of your application concurrently with one or the same server or different server. And then you can like lay out your methods directly within those class. And in the same way as before, you add the decorator for listening to the change of the state. We have decorator that you can import from Trame decorators and just annotate them, and they will automatically get called on your class instance when the server starts. So that's really like a transformations of how we like to bundle a Trame application nowadays. And let's look into more details of what capability you get out of that for free. This migrations or this capability is covered in the guides of the documentation website in the features page, and that was introduced on version 3.9 of Trame. So next, thanks to that Trame app, if you have created such applications using that Trame app abstract class, what you can do is when you use Jupyter, when you instantiate your app, by just returning the instance of your app, you actually get in the cell output the visualization of the Trame app. Of course, you can still run it from the command line and do everything else available, but by default, the UI will be like display properly. There's no reason to await for the UI to be ready, which was the old syntax of doing things. Now the await and the background task execution asynchronous is done totally transparently under the cover for you. And here are two example applications that I will showcase later on as well. But you can see what you can get, at least in the Jupyter context. Staying in the Jupyter, we have we started in some project to work more in collaboration with Jupyter to ease Trame usage and debugging. We've created an extension so the native network can be used instead of the Trame own implementation of the network. And we also added some infrastructure to help expose your application in full screen. When you've got the extension, that's a given. But when you don't have the extension available, we've added this little helper that adjust or add some CSS and allow you to detach the output cell of your Trame visualizations and just have it available as a drag and drop tabs in the Jupyter world. So that could be very convenient. Rather than staying in the like cell output limitation height, you can make it so that you can keep interacting with your Jupyter environment, have maybe your 3D visualization happening on the side, see the data evolutions while you are like maybe monitoring some simulation going on or modifying some arrays on the fly, and directly see the results in an interactive 3D view on the side. So those kind of conclude the way you can like play with Jupyter. And one thing that I forgot is you can always ask what's the URL of that Trame server running in Jupyter, which allow you to just like follow the URL and get a full browser tab available as well. So for example, you've got two screens, you can like just detach a view of your Jupyter environment, put it on the second screen in full screen mode, and still interact with your Jupyter and still monitor live what's happening there. So it's pretty cool. I will show you later on what it looks like. What else? Finally, we are providing a built-in tool for debugging VTK rendering capabilities, especially when deployed in container or in HPC. You may not know, but one of the trickiest thing for the community when using VTK and remote rendering capabilities is making sure that the GPU is getting used. This could mean that the driver are not installed, some libraries are missing, things like that. And with the latest versions of VTK and ParaView, so VTK 9.5 and ParaView 6, we bundle X, EGL, and OS Mesa all in once, meaning that the same executable is capable to do on-screen or off-screen based on what's available out there. But it's important to know which one got picked because I don't want to go into the details, but I ran into some NVIDIA driver bugs on Ubuntu, and for whatever reason, the EGL implementation that was getting used was the Mesa one. So you start with a beautiful GPU capable server, and then you've got pretty bad rendering performance, even though you are using EGL, but you didn't realize that the EGL was used through the CPU and not the GPU. Thankfully, we figure out a workaround, and if you run into that, we've documented some of that on our website, but this tool really helps you to like dive into and really see what's happening in the context that you're running. So yeah, we've created a tool to help us debug what's happening out there sometimes. Next, widgets. There's quite some improvement that have been happening in the recent year, and some of them are really, really big. So while Trame core may not seem to evolve frequently, the ecosystem is thriving with new widgets and new capabilities. For instance, we've been working on providing a much better implementations for doing local rendering with VTK using Wasm. So Wasm is a short term for WebAssembly, and which means that it's the VTK C++ implementation that gets compiled for the browser. And so that's why we've got a really good matching in terms of capabilities between correct VTK C++ and VTK.wasm in the web. So while we've been providing a new Trame widget for it, it also implies a lot of work on the VTK side itself to easily support that. We'll be doing a webinar specifically on that topic pretty soon of VTK.wasm in general. There will be a component of Trame that will be discussed during that next webinar. But if you are interested to learn more about how to use it from C++, JavaScript, or Python through Trame, definitely check out the next webinar on that. I think it's going to come up in September, and if I'm not mistaken, it's September 10th, so mark the date. In terms of add-on widgets, we've also recently added a connector to the DocView library, so you can easily create applications with resizable and dockable views, similar to the tab stuff that you see in Jupyter, where you can drag things, put them on the right bottom, resize them, change the layout. So we've got a new Trame package that does that, where you can place anything you want in it, such as ParaView, 3D view, VTK, or Plotly, charts, whatever. On top of that, we've created a React wrapper that allow a React application to drive a Trame application. Some users really love the capability of visualizations of Trame, and what they do is their Trame app is just a full screen 3D views on ParaView or VTK, but their software stack is React based, so they create the full UI in React, and they just embed the Trame view into it. And what that component lets you do is technically create a bidirectional communications with the React stack. So the React client-side applications then can drive the Trame state or trigger events and stuff like that. So you can communicate through that. It's still like an iframe wrapped into the system, but that's what you can do with that newly created widget. On top of that, we've created an image annotation tool for one of our customers who use it for exploring electron microscopy data. For those who are aware of, is like 4D STEM. Technically, it's like around 700 gigs of data, and that can be produced in 15 seconds. And with that new widgets that they ask us to build, is able to explore the data interactively very conveniently, and is relying on Jupyter to expose the Trame app where the data lives on the HPC and so on. So because many have deployed Jupyter infrastructure on HPC, they end up using that way of delivering some of their Trame app while still keeping access to the big data and resources for loading all of that, which is really cool. Finally, in the medical world, we are working toward exposing Slicer as a web solutions. It's still work in progress, but this involves some work on the C++ classes and some website things for reusable UI and PCs. Some of the code is still private, I think, but feel free to reach out to Kitware if you want to learn more about that. And one thing that they are pushing forward is also having type annotations on the state of Trame. So having the capability of using data classes, which are typed and used inside the state of the Trame infrastructure. So we are not talking too much about it. We are still kind of playing with the design, see what works and how to make it simpler. Once we figure out a path that is really easy to use, I think we will talk more about it. And on that slide also, I wanted to highlight the fact that if you go on the website of the documentation, you look at the widgets, we try to keep up to date with the widgets available in Trame. So you can see what you need to pip install, what the project is about, and how many components comes with that bundle. Before going next,
I'm sorry, Steve.
Patrick. Oh yeah.
Yeah, you have another question.
Go ahead.
So now that React application can drive a Trame application, would it be possible to have Trame directly define and drive a React application from the server side like Dash?
Not as of today, but it's not impossible. Right now, we definitely push Vue forward because that was the technology we've been using for years across our Kitware teams, and that's our preference. But like you mentioned, Patrick, Dash is using the same technology as Trame, where you define things in Python and have them works on the client side in React. So we could create a Trame client implementation that will be based on React, which will allow people to just instantiate their React component in the same way we are instantiating our Vue component and drive them and connect them with those properties and events. In React, it's slightly different, but we can remap those concepts because they are very generic and very, very open. So nothing yet, but if you are interested in funding us to create such capability, Kitware is definitely open for that. Any other questions, Patrick? Or?
No more.
Okay, thank you. Let's see. Well, we get to the live demo. So while we've been staying at a fairly high level, I wanted to share with you some publicly available tools and demonstrations so you can have an opportunity to see what can be achieved with Trame. And I put on that slide a couple of command line. I'm going to use UV because I'm just blown away of what you can do with UV. And by the way, I published a blog post about how to use UV in Trame, and it's just awesome. So let me exit the full screen there. And what I'm going to do is just run those command line. I don't have any virtual environment. I don't have any anything set up. I'm just opening a terminal. Of course, I've got UV installed on my machine. And what's happening here is that it will automatically download in an isolated environment all the dependency of that parsley executable or parsley package. So if I wanted to do it in another way and creating a virtual environment, I will do pip install parsley, and then I will be able to run parsley. But here I just do uvx parsley, everything magically comes on the background, and then the executable runs. What's happening here, you can see that my browser just opened, and now I've got my 3D visualization. So I'm just going to focus on the data, add some grid, only show every 5 degrees of the Earth, maybe add some coastline for Asia. So the data that we are looking at, let me see, I think I can hide that. I should have done that before, but is like some introspections of what's happening seismic wise of the tectonic plaque near Japan there. And this application lets you kind of like interact dynamically with the data by exaggerating the z-scale, adding some coastline that you can see here of the coast of Japan. We can change the highlight or removing the shadow of the 3D view to better understand and see the color map. We even have a capability of creating a custom formula that can be evaluated live to create some dynamic range of the color that you might be interested in. And then we can create more contour so we can highlight things. In that sample dataset that got downloaded automatically with the executable, so I can like demo that easily, I only have one time step, but this application was done for a customer that wanted to be able to export like 40,000 time step in a very efficient manner. And one cool thing here is that we can directly scrub through time and see the evolutions. But then we've also created an infrastructure to create some exports of like movies or images. And we've optimized that in a way that technically the first workflow that customer was doing using Jupyter and Matplotlib to generate some of those charts was taking like 15 hours to dump those 10,000 time steps in Jupyter. So basically you just like run it, go back home, come back the next day and hope for the best. But here we've optimized using some thread pools for encoding and so on. We move from those 15 hours to like a minute and 30 seconds to dump those 10,000 time steps. So it was a huge win in terms of workflow and experience and usage of the applications, and the customer just love it. So this is like an example of what can be done with Trame as one example, like I said. So the next one I wanted to show you was a result of SBIR, some research funding exploring the multivariate view, or let's pretend you've got some data that has the density of various materials, and you want to explore the relationship across those materials. And you can see that there's even like some citations of what's the data coming from. And if you look to the project, there will be also links to the original paper that we reproduced using Trame and VTK. And in that story, we end up like regenerating or producing an application that in less than a week that is capable of loading more than one data set. So we've been able to explore like medical data sets and some AIs, algorithm also with other ways of interacting with the data. And what we are doing here, we've created that custom widget that let us look at the distributions of the data across those multivariable. And with that lens, we can change the opacity transfer functions live, as you can see, like I'm just moving. Of course, there's probably some delay with the recording or the broadcast, but trust me, it's really live on my end. And then you can like just highlight the various regions or area where the iron and CO, sorry, I'm not a chemist, I don't know what that one is, but where the concentrations of iron and CO are getting together, I would say. And this UI allow you to also like clamp the data, look at the distributions, change between log scales and regular scales, rename some of those components of data, adjust the radius of the lens, even swap, meaning whatever was opaque became transparent. What else do we have? We can change the color mapping by just rotating the lens. Let me remove a couple of those. Well, we can use the white background maybe to highlight more stuff. But as you can see, we've created something that was that's very simple to use, simple to explore, simple to look at different data, thanks to VTK capabilities, NumPy, like Most of those operations are done in NumPy under the cover, and just we feed VTK live, and Trame is just bundling all of that and exposing and allowing you to get access to those interactive explorations capabilities. The next one is a Pan3D project that is more focused on X-array, and here the name of the executable doesn't match the name of the package, so I have to do that fancy command line that you're seeing here, because actually Pan3D has a bunch of Explorer, but I can still run it from the command line the same way, where the dependency will be installed for Pan3D all, and then I'm just going to look at the preview. That preview application lets you grab data from local file, remote URL, but I'm just going to pick data from the X-array tutorial. So when I load the data, I've got the metadata informations available here based on the X-array specifications. And then I can choose, I actually want to load this array and color by, so I'm just going to update. So here I just have a slice of the air temperature through time. So I've got 2,920 time steps. So I can like rescale the range based on that given time step. I can crop the data to look at a subset. I can rescale or change the steps of the data to load only a subset. And I've got capabilities of exporting and loading states, so I can come back. But here is just like a simple applications for looking at data that are X-array. And while I'm at it, I also want to show you what it looks like in Pan3D in Jupyter. And I was mentioning X-array. X-array has some plugin infrastructure that lets you add capability to the system. So I'm loading the same data sets, the air temperature from the tutorial as before, but now directly on the dataset X-array, I can ask Pan3D to create a remote rendering of the globe viewer, which is a different viewer than the one we've seen before. And that's what we have here. So we've got the same time control of the data. We can adjust the opacity of the rendering happening. We can adjust the radius, the distance that you put between the data and the earth ground. We can choose the different texture for the earth, and also how we want to render the data that we have, so wireframe or points. And with that, you can adjust the size of those points. So let me actually zoom in. So so those are just like square points, but we can also make them look like sphere if we want to as well. So we can do that, and wireframe with lines or tubes. So that concludes some of the visualizations and presentation I wanted. Well, actually, no, I've got more things. So here I was talking about the URL. So if I click here, I'm opening that same application in full screen, which is still running in the Jupyter environment. So I can still have my Jupyter on the side, interact with it, and play with the data. And I think the last example I wanted to show you is how to use the full screen capability there. So what you can do is, if you do the right click here, you can create new view of cell output. And now I can like move things around. Let me load the data because I didn't load any fields there. So I'm just going to show the V. So here is the data. I can move it below, adjust the size. I can rotate that, or not rotate, but just changing the scale, and then I can like just browse through the data right there and see the slice interactivity. Now that concludes the demo I wanted to do. So let's get back to the slides. Is there any questions before I move on from the demo now that Sorry, Patrick, you're probably answering questions by typing things.
I was answering questions. So it was mainly about multivariate view application, describing the data. It's multiple volumes or one volume with multiple fields. If we were doing volume visualization on each one of those volumes or each one of those fields simultaneously, and then we smash them together, we'd have some occlusion problems, some visibility problems. We wouldn't see everything. So an example I like to think of is that these are like mass fractions for some constituents in each cell. And I want to see those fractions and how they relate to each other across the whole domain. And the widget that you've created basically puts those fields on a color wheel, and the disk allows us to control the visibility and the color of what constituents we're looking at a point in time. So I hope that answered it. Sebastien, did I explain that correctly?
Yes, and I will expand. So I didn't like show another example. So we had someone else also explore the data and other mechanism of projecting those dimensions or those values on a 2D space using some AI algorithm for dimensionality reductions. And we were using a Plotly chart to just project the distributions of the data. And with that, we were able to do selections using the Plotly infrastructure of selections and drive the visualizations, transparency, and so on as well from there, which was really cool because there was some algorithm that was really splitting the domain nicely. And one thing I want to add, so like you say, Patrick, it's one volumes and each field is the density of a given component. So if you just look at one field, you don't know the relationship with any of the other fields. And by doing that wheel things or the projection on a different dimension, dimensionality and doing selections, we are actually kind of like gathering regions where the value of iron is between some numbers and the value of CO is between other numbers and things like that. There's like some relationship that start appearing that if you just look at each of them individually, you will not even see the relationship. It's like the parallel coordinates in 3D for driving the transfer functions. It's super cool.
We have a couple more questions. So I'm going to combine the two questions. Is there an integration with Streamlit for Trame? And can you embed a Trame app into Streamlit using an iframe?
Yes, there's actually, I didn't mention it, but the React wrapper was designed to ease the integration into Streamlit. We do have a Trame Streamlit repository with some example, I think, of integrations using that Trame React. I don't remember the state of that project. It may work or we may have to do like small adjustment, but it is possible and we are really close, if not done, already on that end.
I have another question. Anything special about your Jupyter version in the last demo? So
No, I just pip installed Jupyter Lab. It was probably the latest versions. I know that the CSS things was added recently on Trame in some very recent version of Trame. I was giving a training for the nurse infrastructure, and I've created it because I realized that it was easy to do and convenient, so I ended up just creating it and pushing it maybe a week ago or so. But in terms of Jupyter, I don't know. It should work on any latest version of Jupyter. I don't remember if it was 3 or 4, but both of them works fine, or 2 or 3. I don't remember.
So the next one is the extension for using Jupyter communication. How does that affect performance between Trame's WS Link and the Jupyter comp? Sorry.
That's a good question. It's pretty good, meaning that you may see a little lag, to be honest, when you're interacting, because Jupyter might be busy also communicating, and then you just like get the message, get passed after that or whatever. But it's reasonable. It's really hard to notice anything. One way I can see or mention the lag is when I start sharing different views of the same application on the same server. I'm moving a slider on one, the slider should move on the other one, and it's just catching up, and you just see it like slightly lagging per se. But other than that, when you're just alone and interacting, you don't see much difference.
And then there's a follow-up on the Streamlit. Is there a possibility of posting that link to the Streamlit Tram repo?
Sure. At the end of the webinar anyway, you will have like some kind of survey and follow-up email. We'll provide those informations in that email.
Perfect.
Cool. What else? Well, next, I get you got a chance to ask many questions. No, it's my turn to ask another one. The question 3, what would you like to make with Trame? Is it a VTK ParaView frontend? Is it Catalyst monitors for in-situ visualizations and maybe even steering simulations? Is it analytic dashboard, very similar to what you can see with Dash and Streamlit? Or is it simply moving a desktop applications to the web? Or you are more interested into creating simulation workflow on the web? So for the question seems to be more focused on VTK ParaView frontend, which makes sense. I mean, we've seen some good benefit of creating custom UI, like I mentioned with the seismic stuff, something very fine-tuned. Simulation workflow also is coming pretty close with 63%. Analytic dashboard 38%, and Catalyst like 15%. Okay, that's pretty interesting. So now that you've had the chance to learn more about Trame and see the demo, you may want to try it on your own data. It's open source, so you can clone it from GitHub and get started on your own. We don't expect you to have, but we don't expect you to do it all on your own. We have various levels of support, training, collaborations, customization service available to help you. So if you just need a bit of help, Kitware can definitely go in that directions and provide support. We have discussion forum as well for answering questions directly on Trame. And if your support needs are more extensive, we offer paid support options as well as training courses. Our favorite things to do, of course, is collaborative research. So we work with you and create whatever tool you're looking for. And we love to help and adapt to your needs, either to expand your platform, achieve new research goal, or customize software. I mean, we are software service company, so that's our bread and butter. That's what we love to do every day. I know there's a bunch of long URL in that slide, but don't worry. We'll send you a follow-up email with all those links and for you to have as future reference. And if there's no other questions, I would like to thank you all for joining today and have a wonderful day. Patrick, do you want to add anything else? Or?
No, great information. Thank you, Seb.
Awesome.